this is Ask Datron. This is our sort of inaugural test of our new format. We're trying to do some live interaction here with you guys. So please, if you're logged on, ask us a question. But the idea behind this is, Datrons aren't your typical sort of VMC. You can compare a Haas to a lot of other machines, but Datron is very different than any of those, right? So we want to answer your questions so that you're more familiar with our brand and our technology and what we're good at and what we're not good at. So feel free to shoot us questions and I'll answer them to the best I can, or we'll answer them on a future episode of Ask Datron. So continuing on with that, a few things I want to get out first. If I don't answer all your questions here, feel free to send us an email, visit our website, datron.com, visit us on social media. We're on Instagram, Twitter, LinkedIn, YouTube. We're on pretty much everything. You can find us there at Datron CNC. You can follow me personally at IGS Dan. And just to let you know, we have some upcoming events. I'll tell you all about them later. But the most recent one is going to be in Chicago at UI Labs. At NXT, which is this collaborative effort between the state of Illinois, Autodesk, a lot of other partners. They have a lab there with our Datron Neo, as well as a Parsoon 3D printer, metal 3D printer, and some other really cool technology. We're having an event there April 24th. If you'd like to come by, spend the day with us, come see a Neo up close, and I can answer more questions for you. So come hang out if you make it, if you're from the Chicago area. So moving on from there, what we have are some questions that were submitted through all sorts of social media. So we're going to start with some of the Facebook questions. We're going to start with Joe from Technoware. What is the longest piece of material that you can fit on a Datron machine? So, just to give you a breakdown of our sizes, this is our Neo. This is our smallest format machine, and that's got a 500 by 400 millimeter work envelope. So the biggest piece you can fit on there is really right around 19 inches. When you move up, you have the M8 Cube. This has got a 1000 by 700 work envelope, so 39-inch long part. Going up further from there, you can see our ML Cube. That's a 60-inch by 40-inch, roughly 1500 by 1000 millimeter work envelope. So pretty big, but we actually have bigger than that even. We sell CNC machines that go up to 3 meters long for really long work, especially for like extruded aluminum tubes, things like that, where you need to have really long pieces in there. So, good question. If you're curious, just contact us and we can tell you more about those machines. If we don't have them here, they won't fit inside our building. So, moving on from there, somebody was asking about robotic tooling for our machines. So I'm thinking they're asking about automation, and I've had some other questions about that. Are our machines prepared for automation? So the answer is yes, in a couple of different ways. On the M8 Cube, or ML Cube in particular, you can actually add a pick and place arm to the left side of the Z-axis here, which allows you to do automation inside of the cabin. We actually have several customers with a variety of applications, generally small parts, where they're grabbing a part from here and placing it into a fourth axis for unattended operation, in some cases going for 48 hours nonstop, all inside of this machine envelope, which is really convenient. It doesn't take up a huge space. You don't need a big robotic cell or anything like that. So that can be extremely convenient. And of course, the programming capability is all there in terms of G-code, or in this case, Simple, which is Datron's proprietary language, modeled sort of after C# or Java, but also our MCR format, which has been tried and true for the last 20 to 30 years or so, has allowed us to integrate automation in all sorts of different ways. Okay, moving on from there. Another question from Facebook. Brandon Damasi, is 60,000 RPM a good speed for aluminum? Yes. Next question. No, I'm just kidding. We're going to elaborate on that a little bit. He's saying that he's working on a machine of his own. It can go up to 80,000 RPM. But want to have your head wrapped around those numbers. Well, so the answer is yes. 60,000, 80,000 can be really good for aluminum, or it can be really bad. It really comes down to what tooling you're using. So for instance, we have a lot of single fluid end mills. It's kind of what we're well known for. And single fluid end mills are great for running at high RPM because we have such a large chip channel to evacuate the chips. Otherwise, if you run a tool, say like a 4 fluid end mill, multi-flute end mill, something like that, where you have 4 flutes and not very big chip channels. It could be the same diameter, but it doesn't have nearly as much room to get the chip out. So running a tool at 60,000 RPM, for instance, might not work out well at all. Just because it can't get the chip out, it's going to get molten, it's going to clog up the flute, and eventually just break. So it's all about having the right tools to match the RPM. And luckily, we design our tools in-house. They're counterbalanced, so that even though you're spinning it at 60,000 RPM, you don't have to worry about vibration tearing the machine apart or anything like that. Just as well, we sell some other double flute tools, 3 flute tools. We sell insert cutters like this. This is our monoblock tool, co-developed with Big Kaiser, Big Daishowa. Really awesome for ripping aluminum up. So yeah, the long and short answer is yes, especially as you get into smaller diameters. High RPM becomes really important for the efficiency of the tool. You can't, if we have a diameter like this, spinning it at 30,000 RPM, it's like 3,000 surface feet per minute. So you're really, really efficient with this tool. But as we get down to sizes that are so much smaller, especially like engravers, where the tip size might only be 0.1 millimeter or 4,000ths, you need every little bit of RPM you can get to be efficient with that tool still. So yes, definitely what I would recommend for you in particular, Brandon, so if you go to our website and go to the tool section, there's a drop-down menu. You'll see that if you just click on tools at the top, it brings you to some download links for our catalog, and then also a feed and speed guide that will tell you based on what DATRON spindle you have, so you can sort of figure out from there, based on what sort of spindle you have, what the right feeds and speeds are for our single flute tools. So great question. All right, we're going to move on to Instagram. A lot of Instagram followers hitting us up with questions. Project Zip, I believe, if I remember correctly, you made an awesome Lego DATRON M8 cube, so thank you for that. I think we shared it. His question is, can I have an M8 cube for free? And he already knows the answer, which is no. That's correct. I'm here to confirm that for you. Sorry about that. Versus CNC, shout out to you because you're a big DATRON enthusiast. You use our cutting tools on a non-DATRON CNC machine. I believe he's building his own CNC machines with high RPM spindles, and his tools work out great, so that's fantastic. Has a question about the Neo. Does the DATRON Neo drive system have, on the ball screws, is it belt drive, or what is it? So we have an a Neo right here. And what I'll do is actually I'm going to demonstrate just by moving the axes out of the way. See if we can get a better view of our axes here. So if we pop this open, this is our lead screw for the Y-axis. You can't quite see it that well. So let me take this panel off instead to give you a good view of what the drive system looks like. So right here we actually have our, you see right here we have our direct drive motor connected directly to our ball screw. So the Neo is direct drive on all axes with linear guides provided by Schneeberger. And then I believe that the ball screw is provided by Bosch Rexroth. I have to double check that. But you can see here it's got a Rexroth drive encoder, motor, and then yeah, direct drive on the X-axis as well as the Y-axis, as well as the Z-axis. Direct drive on every axis, which is part of why the Neo is such a quick little machine and has so little backlash. It's so very accurate. So there's that. The M8 cube is also direct drive on the X and Y axes, as well as the ML cube. Those have belt drive Z axes, though. It doesn't hinder performance or accuracy. It was just a height constraint in the design. So for that reason, they have belt drive. I have to check. We have a new machine coming out later this year that I believe is will be our fastest machine yet, faster than the Neo, faster than our M10 Pro, called the MX Cube. I believe that is direct drive in all axes as well. But all our machines are ball screw drive with linear ways. So good question. Thank you, Versus CNC. Next one is from Nerzon2. what is the cheapest 5-axis machine we have? So, generally we're a 3-axis machine tool manufacturer. That's sort of where we shine, but we do have multi-axis options. So, for instance, on the Neo here, we can see there's our optional 4th axis. That can also be used on the NA cube or the ML cube. And we have this question coming later from David. Is it capable of 4-axis simultaneous movement? The answer is yes, it is. Right now, Fusion 360 has some ability to do simultaneous 4. That's the most common pairing we see with the Neo. But I know for certain Mastercan has simultaneous 4-axis moves. So that would be my recommendation if you're looking for a good pairing of 4-axis simultaneous on a Datron. Would be that combination. But as well on the M8 Cube and the M10 Pro, we offer a 5-axis trunnion that fits here in the cutout of the table. So you can see that we have this cutout that we can use for vertical T-slot clamping. We can also use it for a 5-axis trunnion setup. So probably the most affordable combination in terms of machine with a 5-axis capability would be this machine plus a 5-axis trunnion. We also have a dedicated 5-axis machine, 2 of them, the C5 and the D5. C5 is an industrial application, small work envelope, but extremely accurate, high and high linear scales on all axes, high torque motors, deadly accurate. But we also have the D5, which is specifically for dental applications, for dental milling applications. So, carrying on from there. Before I keep going, do we have any live questions that have popped up? Answers so far? Okay, cool. We've got some that we're going to get to in just a minute. How much, this is from Tennis Bats, how much is a Datron Neo? And you're from the UK, so if you actually go and follow Datron CNC UK or Datron Technology CNC UK, just give that a search on Instagram and follow them. You can get in touch with them. You can also contact Chris Sheen. I know that he works for Datron CNC in the UK, and he's the guy to talk to if you're looking for pricing on a Neo in that area. Next is from Machinist Misha, I hope I got that right, also from Europe, asking about what the pricing is like on our machines. So, we get this question a lot, and it varies widely. That's probably the answer you were expecting, but we'll start with the Neo, okay? A Neo starts in the $80,000 range. When you add different options on, it can go higher than that, but that's generally our starting range. And then when you move up to an N8Q, this is in the low $100,000 range where it starts, but quite easily that price can get higher too, because for a couple of reasons. We have a lot of different spindle options. We have different options for tool changers, probes, work holding, automatic doors, things like that that can raise the price. So it really depends on what your application is. If you need a machine that has the widest capability, it will cost more money than the machine that is designed very specifically to do one thing and one thing really well. So for instance, we have customers that just work on, let's say, cutting out tags for graphic panels, something like that, where they need a lot of RPM but not a lot of torque, so they might not need an HSK25 spindle like what we have here. So that would drastically affect the price on tooling, tool holders, the spindle, the tool changer, all of that would change kind of drastically. So it really depends on what the configuration is. But you're looking at, on the low side, $80,000 and then upwards of $100,000 from there. I'm sure I'll get more questions about that anyways, but we'll start with that. Got another question from Mike Clark, ElectroLink USA, asking about the Neo specifically, power requirements for the Neo. So with the Neo, the ML Cube, the M8 Cube, the M10 Pro, pretty much anything on our lineup now, they're all 400 volt, 3-phase, with a 16 amp maximum draw. 50 hertz, I believe. I have to double check that, but 50 hertz. What we usually do for customers that have 480 or 240 or 208 is we supply a transformer that we source from a reputable electrical supply company, and it is rated to step up 208 or 240 or step down 480 all in one unit. That's what we usually supply with our machine, so that you don't have to worry about trying to get 400 volt 3-phase in your facility. It's a European standard, not an American one, so we try to make that easy for you. Other people have issues with not having three-phase power in their facility. It could be in their home garage or shop or something like that. In that case, I would recommend looking into a phase converter. We don't sell them directly. I've heard that Phase Perfect is a good supplier for that. Solid-state phase converters, relatively affordable too. And also really good to have three-phase power for your shop. It introduces a lot of different ability for industrial equipment. So, next question was about axis travels on the Neo. So the work envelope is 500 by 400 millimeter. You have an extra 20 millimeter overall, so 520 by 420 or so to make up for tool overhang. You could probably stretch the y-axis a little bit more, but as you can see here, we have the tool changer in the back. So because of, I have my safety panel up here. We have a tool changer in the back, so it limits you from being able to go too far. The other question, do we have a Neo in our Livermore office? The answer is yes. So we have two offices, one here in New Hampshire, for North America, I should say. One here in New Hampshire, this is our headquarters, and then one in Livermore, California, that's our West Coast office. And then we have machines in a couple of different places. For instance, Autodesk Build Space in Boston is getting installed today. We have the Autodesk facility at UI Labs in Chicago, and then Pier 9 in San Francisco has Neo as well. So there's a few different places to be able to see our equipment. If you're curious what's closest to you, send me a message, send a message to DATRON CNC on social media, Instagram, Facebook, LinkedIn. Just go to datroncnc.com, contact us directly, and we'll get somebody in touch with you that works in your region to try to get you connected. Well, good questions, thank you, Mike. And then we had questions from David on Instagram. He sent me them like 5 minutes before the start of this, so right in the nick of time, thank you. I always like having more questions. So, he had a great question about how easy is it to switch the coolant systems on the machine. So, a lot of people ask, does it have flood coolant capability? And the answer is no. We're not a flood coolant type of machine. It doesn't work real well with the vacuum work holding that we so commonly pair on this. So we're a strictly MQL, or minimum quantity lubrication system machine. And the system that we use is by microjet. And you can actually see, it's a little bit hard to see here, but there's 4 nozzles that surround the tool here that spray a mist of coolant on the tool at all times to keep it cool, to keep the chips, to keep the tool cool, and chip evacuation going smoothly. You can also see it here on the Neo spindle, where we have 2 nozzles here that spray directly on the tool, and they're adjustable, so if you have longer or shorter tools, you can adjust that nozzle length appropriately. So the question, though, was how do you change out coolant? Is it easy to do? Is it difficult? We'll go around the back of the machine here. You can actually see this is the microjet tank. So it's a pressurized vessel, and this is a 9-liter unit. They sell it in different sizes. The Neo has a 2-liter unit. The NAQ can have a 5 or a 9-liter unit. And the way this works is you pressurize the fluid inside. So if I wanted to fill this, I drain all the air from the system, and then up top here, there's a Schrader valve where we thread on a funnel on here, fill it up to the fill line, which is right along here on the side. We'll look through the sight glass, and then when it's full, we repressurize the tank. We're good to go. We can adjust the amount of air we're pressurizing the system with, as well as the amount of air we're using to atomize the coolant, so that you can get more or less fluid versus atomization. So it's pretty adjustable. It's a great system, and it uses very little of this. The coolant that we typically use, we get this question a lot as well, is ethyl alcohol, so ethanol. And we use this for non-ferrous materials. We're not going to use it on materials like steel, ferrous materials, where if there's a spark or something, it gets too hot that it could cause it to ignite. We get that question a lot, and we're just very safe about it. We have many machines out in the field using it safely, and we haven't had any fires. So, worst case, you have somebody in your workplace who's very safety conscious, maybe worried about OSHA or something like that. You can fit a fire suppression system to the machine. A few of our customers have them. They've never had to be used, just serviced. So that's the good news. Changing out the system, we have 2 options. There is a drain here at the bottom. on. So you want it to empty this out, you depressurize it, you open that with a 6mm Allen key, and then drain the system out, close it up, and then fill it with whatever your other cutting fluid is. You could use like an MQL oil, like AccuLube. But my preference is actually to have an auxiliary tank. We actually sell an option to mount an auxiliary tank to the machine, so you can switch connections from one to the other. I believe it does it automatically with solenoids. So that you can have one tank just for oil, one tank just for ethanol, and be able to switch quickly between the two. That way it ensures you're not mixing some ethanol with some oil and vice versa, which would create sort of a mixture that might not be desirable for your finished product. Probing and fusion. Asking about the ability to use Fusion 360 for some probing routines, and asking whether or not we have that. Is that a feature that's coming or not? The short answer is, as far as I know, it's not currently available for our next control. It is something that's available for HSC Pro, which is our legacy control at this point. We still offer this control on our M8 cubes and our ML cubes, but it's a little bit, compared to Next, it's not as streamlined. It's still fully functional, and we have the ability to do probing through Fusion 360 on this control. With that being said, you have the ability to program it here at the terminal, as well as use the camera for automated probing. I'm thinking most people, if they know our Next control, they know the Neo, they probably know about our pretty awesome 3D probing setup on this. Quite a bit different than if you're used to using, say, a Renishaw probe in a Haas. With this, we use the camera. So basically, we see what our Z-axis sees. So when I want to probe something, I drag the machine where I want it to probe, and the machine will move around following my touch. So in that way, it's extremely easy to use, but it gets even easier when it comes time to probe something. So here, for example, is a piece of material set up on our pneumatic vices. And if I want to probe the center of this, I don't need to input any numbers. I'm just drawing the feature that I want to probe, and it will plot out the points for me. Then from there, I can adjust the dimensions of it by hand, change where it measures for Z offset, change where it measures an edge. Both edges, I can drag them inside if I want to measure the inside of a feature. I can also measure 2 points along an edge to find the rotation of it. So this, for short run sort of work, is what we're commonly recommending users use. You could do it through Fusion, but I actually think it's quite a bit easier just to do it at the control. A really neat feature is that when you post out of Fusion, it's posting all your workpiece dimensions and also your origin location, so that when you go to probe, it presents an image of where the origin is set on that part. So it makes it really easy for a non-machinist to be able to walk up and figure out quickly, where do I probe this part? Okay, for instance, I can pull one up. I have a program on here. So we'll do load program. So it's loading it in right now, and it shows here, program origin of the workpiece is top center of my stock. And it pulled that in from the file that's in our editor. Gives you all the information here about cutting tools, about workpiece dimensions, the geometry, etc., etc. So probing is extremely easy on this machine, easier than if you were to do it in Fusion, I would argue. But I believe the functionality is coming. I've worked closely with some people at Autodesk, and there's actually some really cool functions that I believe are coming to Fusion in the not too distant future. So I'll be talking more with them and DATRON about collaborating to bring some of those cool functions to Next. Good question. And then I already talked about 4th axis simultaneous on the Neo. We're good for that. Nothing to worry about there. So yeah, that is all the questions we had submitted right before the start.
We have a couple here. Kevin Chris is asking, is there a way to update the current software on my machine? The new DATRON Next software looks so great.
Yes, it does look great. Hi, Kevin. We were just actually on email, I think, right before this. So if you're running a legacy piece of equipment with like the M7 or an M8 that has version 9 control, or you have an M8 Cube with HSC Pro control, those are not able to be converted to Next control There's unfortunately a lot of differences, not just at like the control level, but the PC that's used for that. This actually has a dual PC setup, so it has one PC dedicated just to the user interface, and then it has another PC in the back dedicated just to the back-off drive controllers. So it's a much more elaborate system. There's different safety measures integrated into it as well. So unfortunately, they're a little bit too different to convert. But good question. And Kevin had a question earlier I forgot to answer here about milling titanium on our machines. Do we do it? If so, what sort of feed and speeds do they use? Good question. So it depends. The answer is definitely yes. For instance, the D5, our dental milling machine, was designed for milling titanium implants. So it actually has milled a whole lot of titanium for a lot of people's dental implants. And the methodology with that, since it's, I believe, grade 5 titanium, which is some pretty hard stuff, is to use sort of typical 4-flute tools with the correct kind of coatings. There's a lot of tools in our catalog that are ideal for that. We actually have a whole dental tool catalog dedicated just to that need. But we have lots of different coatings, multiple flutes, 4 flutes or more in some instances, with suitable edge radiuses to avoid wearing at the tip in grade 5, which is a pretty tough material. Now, grade 2 is a little bit different of a story. It's much more chemically pure than grade 5, which is a 6Al4V. Which has a much higher hardness than grade 2, which is like 99% titanium. Grade 2 has got this bad reputation of being really pretty soft and gummy to work with, bad like copper or a 3000 series aluminum or something like that. So here's the good news, is that we've been doing some testing ourselves with titanium lately, as well as some of our users of our tools have been testing with high RPM spindles, and they've shown a lot of promise in using, believe it or not, something like a single flute tool to mill titanium with good results and actually pretty acceptable tool life. The reason being is because titanium is so soft. If you actually look at grade 2 titanium and look up the description, sort of the material data sheet, its hardness is actually lower than 70-75 aluminum. Which is perfect for these tools. And it does have some work hardening properties, so we're still trying to figure out what the ideal feed and speed, what the limits are in terms of cutting speed, but we're learning a lot with that. So we've had some success along the lines of cutting grade 2 titanium, something that most people usually struggle with. So really good question. I hope to have more information about that in the upcoming months.
We've got another question from William Malden, asking if it's possible to use DATRON vacuum tables in a non-DATRON machine.
Awesome question. The answer is yes. There's a couple of different styles that we have. So one, for instance, is, I'll go to the ML Cube over here. We have a lot of filming equipment on that side. This is a little bit easier to access. So the ML Cube has our biggest possible vacuum table, well, not our biggest possible, but one of the biggest possible vacuum table setups, which is our meander style S-groove pattern. This is really ideal for holding parts about this size, so about 2 by 3 inch or so. You can even go a little bit smaller than that. You just might need to deploy certain strategies or have a more high-powered vacuum pump. But we actually designed another vacuum table called the Vacuum 8. Which we have one set up on the M7 over here, which is right now covered up and locked down, but it's a 12 by 18 modular design, and with this, it's actually designed specifically for holding smaller parts. We're talking more in the 1 square inch range. We actually designed another table, the dense hole pattern for Vacuum 8, that can work with under 1 by 1 inch. So they're really quite an awesome work holding technology. They can be fitted to other machines. Sometimes the strategies don't work quite as well. Part of our advantage is we have higher RPM spindles on everything. The lowest we go is 30,000 and the highest is 60,000. So we always have enough RPM to work with the really small tools that work well with cutting out parts on a vacuum table. So if you have, say, a Haas or a Mazak or something like that, and maybe you have 12,000 RPM to play with, it might be a little bit tricky holding really small parts on a vacuum table just because the cutting forces are intrinsically higher. So what I would recommend is reach out to us on social media or through our website, and we'll get you connected with either myself, someone in our applications team, or someone in sales to find out whether or not maybe a vacuum would be a good fit on your machine, or maybe you need to go a different direction. We like to basically just tell it like it is. If a Datron's a good fit, or Datron technology like vacuum work holding is a good fit, we want to encourage you to go that direction, but if there's a better option, we'll let you know, because nobody likes to get sold something they don't need or won't work, right? So, really good question. Yeah, there's actually quite a few users who have Datron vacuum aids on non-Datron equipment with a good rate of success. So, great question.
One more question from Kevin. It looks like maybe we touched on this before, but wants to know if there's a touch probe on the Datron Neo.
Yes, of course. So actually, what's notable about the Neo is that's a standard feature. Part of why it's kind of hard to give you a price on the M8 Cube is that you can buy this with or without a probe. You can buy it with or without a camera or a vision system, or many different spindles, multiple tool changers, etc., etc., etc. So you can configure this in 11 million different ways, I should say. With the Neo, its base configuration is actually pretty good. It comes with a 40,000 RPM 2 kilowatt spindle, comes with the integrated touch probe, comes with the integrated camera that we were demonstrating on the M8 Cube, an option on that machine. Comes with a 24 station tool changer, comes with our next control. Yeah, it comes pretty well loaded. The only thing it doesn't come with, cutting tools and work holding. So from there, you add on either one of our work holding accessories, which we have mechanical style vices provided by Shunk, and then we also have pneumatic clamping systems with T-slot tables that work really well for quick, easy part setup. And then of course we have our vacuum table options. So the Neo over here, for instance, has a miniature version of what you saw over there on the ML Cube. This is a 500 by 200 section. You can have two of those. Vacuum is routed through the table. I should mention, this style vacuum table is not fittable on other equipment. That's sort of why I was showing it on the ML Cube earlier, is because it's mating to our conical grids system, which I can talk more about later. But it's also lining up to vacuum ports that are here on the table. What that means is that it doesn't fit so well to other equipment where the vacuum aid does. It's plumbed differently, so it works quite well on other pieces of machinery. So, great question.
Close it up.
What's that? Close it. Oh, okay.
We're all done.
Okay, super. So, thank you all for joining me for our first Ask Datron event. I wanted to just remind everyone some of the events that we have coming up. So, April 24th at UI Labs in Chicago. That's NXT Autodesk collaboration at that facility. That's coming up, yeah, April 24th. UI Labs, Chicago. Come visit us, spend the day. Send us an email at datron.com or go to social media. Reach out to us if you want to get hooked up with that, and we'll get you passes to attend. We also have some great events coming up. We're doing East Tech, which is in Springfield, Massachusetts. That's coming up. I had it written down. I lost my paper. It's coming up in May, May 14th, 15th, and 16th. Then we have 2 Tech Day events in June, one here in our East Coast office and one in our West Coast office. That's June 5th. And then later on down the line in September, we have West Tech out in California. We'll give you more details about that coming up. But please visit our website, datron.com, or follow us, Datron CNC on Facebook, Instagram, LinkedIn, Twitter, YouTube, MySpace, everything. We're there. Maybe not MySpace. That's probably a little passe. That's it for now. I'm Dan DeMajor. Thank you for joining us, and we'll talk to you next time.